In this video, we're going to be looking at IP addresses. So, what is an IP address? An IP address is a unique identifier assigned to each device connected to a computer network. The most common analogy for an IP address is the postal service. For the postal service to work, every house needs to have its own unique address. And if you need to send a letter, not that anyone sends letters anymore, but you need to write the destination address on the envelope. That way, when you send the letter, the postman knows exactly where to deliver it. Now, the address must be unique. Otherwise, your post could end up going to somebody else, or you could start receiving somebody else's post. And that can sometimes not go so well. Computers work in the same way. Each computer in a network needs to have a unique address, called an IP address. And when sending data to a computer, just like letters, we need to add the destination address. We also need to include a return address, so they know where to reply. So, let's look at an IP address. This is an IPv4 address, which, at the time of making this video, and probably for a long time after, is the most common. Although we are slowly moving over to the new IP version 6, that will be covered in another video. So, an IPv4 address is 32 bits in length, which means it contains 32 binary digits. We'll look at this more when we go over subnetting. It contains 4 sections, which are called octets. These octets are separated by dots or periods. Each octet, in theory, can contain any number between 0 and 255. Why 255? Well, our 32-bit number is separated into 4 lots of 8, and 255 is the largest number that can be made from 8 bits. Now the address itself is separated into 2 parts. The first part represents the network, and the second part represents the host. To know which part of the IP address represents the network, we used to rely on the first few binary bits. But since the early 90s, we have something called a subnet mask. A subnet mask is always paired with an IP address, and is used to identify the network section and the host section of the address. In its simplest form, whenever you see 255, this is the network part of the address. Whenever you see a 0, this is the host part of the address. It can get a bit more complicated than that, but we'll look at that later on down the line. When learning about networks and hosts and what they mean, it's good to think of it like your address. You share the same street name as your neighbors, but it's the house number that makes your address unique. On the other hand, you can also have multiple streets with the same house number, and it's the same with computer networks. Instead of street addresses, you have network numbers, and instead of house numbers, you have host numbers. Here we have 2 networks, 192.168.5.0 and 192.168.10.0, both with a subnet of 255.255.255.0. When talking about networks as a whole, you often just use 0 for the host section. Inside our networks, we have our hosts, .1, .2, and .3. It's common in a network diagram to just show the host section of the address if you already know the network section. In fact, these IP addresses would be 192.168.5.1, 192.168.5.2, and so on and so on. So, with all of that in mind, if we had some data to send to 192.168.5.3 with a subnet mask of 255.255.255.0, where would we send it? Well, if we look at the subnet mask, we can see that the network is 192.168.5. So we know that 3 is our host number. So we send it over to the host in the network on the left. Hopefully, That all makes sense so far. Back in the early days of IP, it was decided to split all of the available addresses into groups, and these groups were called classes. The idea was to make address allocation scalable. The main ones being Class A, Class B, and Class C. There is also Class D for something called multicast addresses, and Class E, which is reserved for experiment to use. We're going to focus on the first three. Each class has a range of IP addresses. Class A addresses are between 1.0.0.0 to 126.255.255.255. But subnet masks are of 255.0.0.0. Class B addresses are between 128.0.0.0 to 91.255.255.255. Subbing mass of T55.255.0.0. And Class C addresses are between 192.0.0.0 to 223.255.255.255 with a subnet mask of 255.255.255 Whew. After that, number and a say 255 again. So this was all to control the number of hosts available on each network. Class A has 3 octets available for host allocation. This means we can have 16,777,214 hosts for a single Class A network. Massive networks. Class B has 2 available octets for host allocation. So we can only have 65,534 hosts to a single Class B network. Still a very big number. Class C only has 1 available octet for host allocation. So this means we can get 254 hosts per single Class C network. So you need to be able to look at an IP address and know which class it belongs to. The easiest ways to do this is to memorize the first octets. If an IP starts with the number 10, straight away you know it's a Class A network. If it starts with 192, you know it's Class C, and so on and so on. But there's a problem. The problem is, no one could have predicted the massive explosion of computers and the internet. In fact, there are no more unallocated IPv4 addresses left. This is why the new IPv6 has been designed. It will give us more than enough IP addresses for absolutely everyone. But fear not, there is a solution to help prolong the life of IPv4. The solution is to carve out small sections from all 3 classes and call them private IP addresses. All other addresses are known as public addresses. They still use the same subnet mask for that class, and they can still have the same number of hosts. The difference is where public IP addresses need to be unique. Private addresses can be used over and over and over again, thus saving millions or billions of public IP addresses. This is how it works. Let's say this is your house. You have a PC, a phone, and a printer. You can choose any private IP range that you want to use. In this case, we would choose Class C 192.168.1.0, and we'll assign our IP addresses. Remember, this is a Class C network, and the default subnet mask is 255.055.055.0, meaning 192.168.1 is our network address, and the last number is our host address. So all of our devices can talk to each other without any problems at all. The beauty of private IP addresses is that they can be used by anyone. For example, your neighbors might also be using the same IP addresses as you are, and that's fine. Private IP addresses only need to be unique within your own network. There is a catch though. Private IP addresses cannot be used over the internet. Otherwise, we would have duplicate IP addresses everywhere, and data would never end up getting to the correct places. For that reason, only public IP addresses can be used over the internet. These must be unique. When you sign up with your internet service provider, they will issue you with a public IP address that you can use over the internet. Usually, they give you just one address, not a block of 65,000 or 254. This helps prolong the life of IPv4 because instead of using an IP address for every one of our 6 devices, we are only using 2 public addresses. The way our devices will communicate to the internet through the public IP is by using something called network address translation, which again we will cover in a separate video. Before we finish this video, I will show you how to check your own IP addresses at home. On Windows, you simply open a command prompt or PowerShell. Type ipconfig to see your interface settings. Find your interface. You might have more than one if you have wireless, and you'll be able to see your IP address and subnet mask. Linux or Apple computers, open a terminal and type ifconfig, and you should see the same information. To view your public IP address, simply open a browser, go to Google, and type in "What is my IP?" and it will show you your public IP address.